The only circuit breakers that are in the cockpit are the 8 circuit breakers right located here. When we boot the aircraft up, you'll see all the electronic circuit breakers that a pilot can control through the avionics system. So as we get going here, I'm going to turn on battery 1. As battery 1 is booting up, we'll talk a little bit about each of the screens. We have an emergency flight display, electronic flight display, our ESIS on the left-hand side, our pilot display, multifunction display, 2 here, and then of course on the right there's the co-pilot PFD. Below that, this is the only touchscreen on the airplane. It is our data entry here. It's our touchscreen controller. As we move further back, one of the interesting things to see here is what we call a cursor control device. As I use this, I can control the different settings on the screens. The button on the right will allow me to shift between each screen. As you look up right here, you'll see this here move between screens. My cursor ball here, you can see as it moves, I can control the ball. Again, I have a scroll wheel right here, so I can scroll in and out. I also can make different selections on different screens. And then the left button allows me to select an item. As we bring on battery 2, what I'm going to do is I'm going to show you how we can go ahead and upload a flight plan from ForeFlight. So right here I have our planned flight from BJC to Spearfish, or Rocky Mountain Metro to Spearfish. I just need to connect to the aircraft, which I'm going to do under my settings and Wi-Fi, and then I will connect to this aircraft, and then we'll send the flight plan to the aircraft. Where this becomes a benefit is that if you have ForeFlight dispatch, or you've created a variety of different flights, you can send them directly into the aircraft and then upload them from there. So I just sent the flight plan into the system. I can then go ahead and then go to the gateway, find my flight plan that's in the system, which is the one down here at the bottom. I can select that and insert it into there. It's also winded, and it has all your primary data in there. Then if I want to clear out anything that is uploaded in the system, I can quickly do that through ForeFlight right here and clear this out. So the next thing we're going to do is we're just going to load the FMS. So I'm just entering in our planned route of flight right here, or our additional items. And as you see, I'm entering right here. Up here is the data fields that I am entering into. So we have our flight plan loaded in the system. Now what we'll do is we'll go through some checklist items, and I'll show you a couple things that are nice that we have set up here. So there's a checklist button. So when you're flying tomorrow, you'll have the trim buttons selected right here, autopilot disconnect, the TCS button, your button to push to talk right here. There's also push to talk, so you don't have to touch the yoke on both sides. And at the very top, there's a checklist button. So now we're going to go ahead and do a couple items on the checklist, so you'll see the different synoptic pages change. So as I run through my electronic checklist right here, when it gets to an item where I need to look at a synoptic page, you can see how the synoptic changed from the main synoptic to the electric synoptic, so now I can check the battery level on those different items. One of the neat things about the cockpit is its simplicity. Everything is operated primarily through the avionics with my touchscreen controller, cursor control device to enter or control items. But of course, we always need to have some backups, and there's always some hard switches. So across the top here, my lights are all manual, and I can select those on as necessary. My engine start switches, batteries and generators, cabin lighting in the back. As we come down here in the center console, most of these items are for abnormal operations. As you can see, the windshield heat, it's auto high. So if everything's functioning normally, you just leave it in auto. The same thing with the bleed sources. Same thing with your ice protection system. And then over here, likewise on your cabin dump switches and your manual control of your pressurization. Those only need to be activated if there's an abnormal situation. A neat item about the dump of the cabin, if you're at 45,000 feet, dumping the cabin to 45,000 feet is probably a bad idea. So the system protects itself no matter what altitude you're at. If you hit the cabin dump, it will only dump to roughly 14,200. So it affords you the opportunity to evacuate smoke and fumes, having a quick change of pressure, but at the same time too, it's not going to take you to an altitude that you could lose consciousness. The system has an emergency descent mode. If you get a cabin altitude light and the autopilot is engaged, the airplane will do a 90-degree turn, descend to 15,000 feet, and slow to 180 knots to allow you to regain consciousness and protect you automatically. The auto throttles will engage to get you down to that altitude. Here in the center console here, we just have lighting control for all of our screens up in the front. As we get down here behind the throttles, actually to the left of the throttles is your air brake, to the right is the flap system. Here are manual trims, secondary trim for your stab, your primaries right here, aileron and rudder trim. As we discussed with the auto yaw trim, the need to use the rudder trim is minimal, if not completely absent when you are using an aircraft with the auto yaw trim on there. A couple emergency systems in the back here to include emergency ram air. Again, by opening this, it will not depressurize to ambient. It will limit the pressurization to the mid-teens. And then this here is our emergency gear extend. On either side, you have your oxygen, push to talk button. You have a cubby hole behind you, drinks here. On the pilot side, you have the ability to select the cabin passenger oxygen to off, auto, or on. As we come over here to control the autopilot, we have our autopilot, our AFCS controller right here. You can see there's an auto throttle function on it, and we'll be using all of that tomorrow. We're going to take a look at just some of the weather features that we have on the aircraft. The first one is XM weather. You can see right here. As I zoom out here, we can see the weather. You can see we have a couple storms right here with the XM weather. We're displaying those weather cells out in the area. One of the nice things about the XM weather that I really like about it is that it has a neat feature for winds. If I go down to the winds tab here, I can bring up the winds for a variety of flight levels. So we'll be at 450 here. And once the winds build in, right now it'll take a few minutes for the winds to be acquired through XM. We'll see the winds displayed up on our iNav map, but also down here it will convert it into a headwind and tailwind component for us. So you can see here, as I've displayed the XM winds, you can see that you got the wind direction and the wind barb for the altitude that is selected. Right now that's at 450. But what's really nice about this system is I can put that wind display on my vertical situation display, the VSD. And when I do that, I can actually see what the winds are corrected for headwind, tailwind. And what it really helps me out with is if I need to either descend or climb to get to a better place where there might be a wind level, wind shear area where I can get a better tailwind or a less headwind. Another nice feature of the aircraft, we have graphical weather, which is worldwide weather. Worked off the VDL mode too, so in areas where you don't have XM, when you're in VHF range, you can pull down weather. It's a fixed picture at time, but this will give you an idea of what would be displayed in areas that you do not have XM weather. You can select the flight plan tab here and it will cover the areas for your flight plan, and now we're going to get that through our data link system, and that will display here in a minute. There we go. So already displaying it, already So you can see right here, I'm getting a similar information that we were seeing from the XM satellite. You can bring in XM weather rather. You can bring in satellite winds, as you can see here, and the radar picture. So this is a fixed time. You'll need to update it every so often, but it gives you a God's eye view of what the current conditions are. If you notice on the Pilot PFD, it has symbology that you might not be used to seeing. That symbology is what we call a flight path system. So what we have, which is unique to my understanding with the Honeywell system, is conformal synthetic vision. What conformal synthetic vision means is that the synthetic vision is adjusted along your flight path. So whatever is off your nose is where your aircraft's flying. What does that mean? So on non-conformal synthetic vision, if you have a large crosswind on final, your synthetic vision won't display the runway that's actually in front of you because it is based off where the nose is pointed. On a conformal system, it's where the aircraft is actually flying towards, and therefore that would be displayed on your symbology. What that allows us to do is have a flight path system. As you notice over here on the display, this is our path, which is level, but you can see that on the outside is our pitch. So on the ground, we're approximately 1 degree to 2 degrees nose down with the nose wheel on the ground. And that is how it's displaying. You can always select the other traditional cueings where most people are most commonly used to seeing the single cue. You can see in the single cue, it's a pitch-based system. The flight path vector is in the background, grayed out. It's still conformal synthetic vision, but your flight director is now not based on where you're flying towards. It's based on the pitch of the aircraft to get you to that flight path. The cross pointer is another method to look at for symbology. So next thing I'm going to show you is the TCAS symbology. It's kind of a nice setup because, traditionally on older TCAS systems, you had to move your VVI into a green zone, and of course the VVI or your VSI lags. And so it was difficult. People would either overshoot or undershoot the recommended climb rate to avoid the conflict. In our system, it's based on your flight path. So all you do is move your flight path symbology into the boxes that will be displayed here in a second. So you can see all I have to do is move my green flight path vector into that green box, and I will avoid the conflict. If there's a conflict,
TCAS system test okay.
If there's a conflict above, the red would be displayed above the aircraft. But yet again, all you have to do is move your flight path, which is much easier, into the TCAS avoidance box. So we have a data link system, which is used off of our Radio 2. On this data link system, I can gather weather for where we're going. So this is another means to get weather. So we have XM for your traditional what XM provides to include METARs in a local area. We've already gone through the graphical weather, which is worldwide. That comes through the VDL mode 2. That provides you the satellite, radar, or winds. But this system here will then allow me to get METARs and TAFs from certain locations, and also digital ATIS. So we'll get a message here in a second. We got that message, AOC uplink. When I see AOC uplink, I'll go to new message down here, and I can just check the weather conditions at the METAR and TAF. Additionally, I can request digital ATIS. All you have to type in is an airport that you know has digital ATIS available. So that was a signal telling me to look at my CAS message. I have an ATS uplink. So when I go to the ATS uplink, I can get my Denver digital ATIS. So it's not just the weather, but you can see here you're getting your actual ATIS, so you don't have to be listening to a radio at the same time. to get your ATIS information. While we're down here in the data link portion of it, I'm going to switch to FANS 1A. The airplane is capable of CPDLC. It's controller pilot data link communications. Okay, and it allows you to essentially text message into your FMS route changes. They can ask you to change altitude. They can also give us different frequencies. So we're going to log into a FANS 1A CPDLC. You see FANS 1A right here. I'm going to go to the login page. I'm going to type in KUSA. And then we're going to go ahead and log into the system. So you can see here, log is accepted. Once we climb into the Denver Center's airspace, we'll get a message that establishes direct communication, and from there they can communicate to us. Frequency changes is what's most frequently used, but you can get route of flight changes, altitude requests. When the radios are quite busy, it's a great way to communicate and get what you want, and it reduces the workload for both the pilots and the controllers. Another benefit to the iNav is our map here displays all the taxiways, and I can highlight each of those. If I was told to go from Delta to Golf, I can highlight Delta. There's Delta 5 and Golf as I go along the route of flight. I can also use my charts down here, and you'll see that the aircraft will be displayed on the chart. We're in the upper left corner here. So I have two means of seeing where I'm at on an airfield to help myself navigate through the ground environment. Also, during your approach, if you're flying an approach into here, Rocky Mountain Metro, you can see that you have the airport is on the display of the chart. You also have this nice feature where you can split the chart. So you can look at the header down here, minima, which is displayed at the bottom, or profile. I generally like to fly like this so I can see the profile down here and I see the plan view once I got all the data entered into the system. Some other neat features of the aircraft are frequency changes. The first thing with the frequency change, it's quite easy. The touchscreen controller is really handy. If I wanted to change the frequency in COM1, I could just go to put the tower frequency in, swap and close. So now just typing that in, it came up to my right up here, and it swapped in that frequency straight into the radio to talk on. You can also do that with your nav frequencies. Another thing that's nice is when you come up to the iNav map here on your 1.6 window, the waypoints, I can select show info. So I'm showing info on Spearfish. If I haven't flown there in a while, I can't remember what the frequencies are, I can select that AWAS frequency. When I select it here, I can send it straight to COM2. And you can see over here, that went straight into the COM2 radio, and I can swap it in. Notice I did that all with the cursor control device, so I don't even have to be reaching around the cockpit to enter the data in. Under that show info, there's a variety of other information, such as FBO. Again, you can send those frequencies in, hotels, a variety of other stuff that is loaded with the database. Another option is the weather. The weather here for the METAR. This here METAR comes from the XM. The METAR on our touchscreen controller came through the VDL Mode 2, which is the APHIS data link subscription. Let's say I need to see more waypoints. My 1.6 window here with my FMW, flight management window, might be taking up too much space. I can select this and make a much longer screen, and now I can see more of my waypoints. So I can move and use these screens around as I see fit. Another idea here is, remember when I went to charts, well, I have to be able to see my synoptic all the time. So that synoptic actually shrunk down into this window right here. So I have all the same information that I have on my synoptic page displayed just slightly different. If I were to bring the synoptic back here, then whatever was in the 1.6 previous, which was the checklist, will display right there automatically. So we have a variety of TCAS here. You can select on the aircraft ground. We've gone through the weather that we can select. We can also turn all the weather off on the display, and now I can display terrain. We'll display any terrain or situational terrain, whether if you're flying in a low valley and terrain is your bigger threat to you than other aircraft, you can bring that up on the screen and or weather. You can highlight as much as you want for your map. You can clutter it or declutter it as necessary with this selection. And again, same thing with your flight plan. You can display your alternate route of flight. Here you can display all your airspaces. One of the ones that I like is being able to display special use airspace and en route airspace. The TFRs are displayed through XM, which is this location right here. And if there's a TFR in the area, which I know there's one planned to be here in a few days at Spearfish, I can actually hit skip waypoint and it will skip the waypoint to that location. And we can see if there's a TFR right here. Oh, here we go. Here's a TFR right here. But you can see it active. That's a fire TFR. So you can avoid TFRs in flight through XM. Let's go through the different synoptic pages to give you an idea of what is displayed. We have an engine display here, which gives a slight bit more detail than your engine displays, which are on your PFD at the top. Gives you some statuses of your fire bottles, in addition to all your regular parameters. Fuel. We got a fuel display right here. This is fuel quantity to grade. Once the engine starts, that will clear up. It gives you an idea of your fuel quantity, what's in your collector tank, which is right here, the temperature of your fuel. One of the neat things about the PC-24 is that PRIST is not required. All the fuel is heated before it enters the engine. Therefore, as an anti-icing additive, PRIST is not required. You can see right here, this is your fuel. You can see your fuel shut off, the pressure, pounds per hour per each engine. Right here, all the fuel balancing is automatic. These valves will open up and also command on as necessary. To give you an example, what we'll do here to see what it would look like, since we most likely won't see it in flight, we're going to go ahead and transfer, and you'll see how that works. We'll transfer from left to right. You can see that the pumps come on automatically, and it will pump. All the valves will open automatically. There you go. Now you're starting to see it starting to fill from the left to the right side. We'll let that run for a second since they didn't fuel it evenly. So all these items I can manually manipulate, or I can leave it run in auto. So the fuel transfer is within tolerance, so the pump will shut off, the valve closed. But you're able to see everything that's happening on your synoptic pages. Electrics, you can see we have our lithium-ion batteries are fully charged. You don't use a voltage for the start, you use a state of charge here. As long as this is green, you can start the engines. Here's electronic circuit breakers. You can see there's a lot of them, but I can page through these as necessary. A pilot can take actions under the MMOP to disable a system. It used to be that for hard circuit breakers, a maintainer would have to come out, pull a circuit breaker, and then you'd have a maintenance action. Here, pilots are authorized on certain items to use electronic circuit breakers. To give you an idea on how that functions, we'll use the aileron trim here. I got an aileron trim highlighted. Now I can set that to out, and the circuit breaker goes out. Now my status page, what I'll see here is what are tripped circuit breakers. There's none that are tripped. However, there's one that's out that I selected to out. I can reset that to in. It will go to in. And then I can continue to go through all my different statuses. Locked are equipment not installed on the aircraft. Fail is if they're obviously not functioning. And then all the circuit breakers are in. And you can see here the aileron trim is back in, as we just described. All right, brakes. Here's our brakes on the aircraft. We'll just go ahead and set those real quick. You'll see the pump run. So now the hydraulic pump is running. That's the electric hydraulic pump that you hear in the background, and it's pumping up the main pressure on the brakes. And then this is your emergency and parking brake pressure. I'm just releasing that here since we have the aircraft chalked. But if you notice here, as I pull that, do you see how this goes green right here on the screen? When I release the brakes, parking brake, lights go out, the valve closes. So everything is monitored, and it tells you the status of everything just to the little thing of your parking brake is set. Not just the parking brake's lever is set, but it actually will tell you if the actual pads are being depressed against the in the system. IPS here is our icing protection system. You can see right here, if we fly into icy conditions, these ice detectors will detect ice, and we'll get an ice light here and right here, and then all the items that will come on and go green as they're functioning. As soon as you exit the icing conditions, it will terminate and complete its cycle. And down here is your ECS. We have, obviously these temperatures are quite high for your filming. We have 2 evaporators, 1 in the forward, and then actually 2 in the back. But these are your cooling settings, heating, and these are this is bleed air. It can cross over or it can go direct in. But I have a lot of different settings on this. And then we go back to close, and we go back to system summary here. So on your system summary page, we have the fuel right here. We have our flat positions, and then our landing gear, which are down. TAT is your total air temperature. The position of your stab, aileron trim, and rudder trim. Electric status, environmental, so the airfield that you're going to with its field elevation allows it to calculate the appropriate climb schedule for the pressurization and descent schedule for pressurization. You can see we're obviously on the ground. Our pressure differential is 0, and our cabin altitude is 5360. Down here is where we can control the temperature. We have a couple sliders to make that work. So for demonstration of our checklist system, I'm going to go ahead and pull the oxygen lever out. When I pull the oxygen lever out, of course, I've turned oxygen off. I get a master caution, which is red, and you can see right here I have a red number 1. So that means I have 1 red CAS message. So I have the option to use my paper copy, my electronic iPad copy of the checklist, or I can actually go into my checklist item over here. So I can come down here. You can see abnormal. But if I went into abnormal, I'd have to search the entire abnormal checklist to find oxygen off. But if I select active Q right here, it knows that the oxygen was the one that is highlighted right here, and it will bring that checklist automatically up for you. So now we can go through and run the checklist in here. So we would do these. You see how it swapped when I went down to ECS Synoptic? It brought that Synoptic up for me automatically. You can see here, it's telling me how much oxygen I have on board the aircraft. And of course, I'm not running these steps here, but it gives you an idea of those checklist items there that we'll run through, and the synoptics are linked to those items.
If you liked the cockpit, I promise you'll love seeing this airplane in action. And in the video on the screen, we got to fly the PC-24 down to a dirt strip to show just how versatile this airplane really is. It was an amazing adventure that I promise you don't want to miss. So that video is on the screen right now, and I'll see you there.